Inside silicon, the technology behind everything. Powered by Semionics.
All right, let's talk about how this tiny piece of silicon, something literally thinner than a human hair, somehow became the single most fought-over object on the entire planet. This is all about silicon strategy.
If you go back a century, it was all about oil. Global power came down to who controlled the oil fields, who controlled the shipping routes. Nations would literally rise and fall based on their access to this one thing. It was tangible. You could see it. You could touch it. It defined an entire era.
But today, that power is decided by something a whole lot smaller. We're talking about a piece of silicon, so thin you can barely see it. It's designed in one country, it's actually built in another, and it has the power to reshape pretty much everything. Economies, warfare, and of course, artificial intelligence itself. So this is the story of how that tiny, tiny chip became arguably the most important object in the world.
So people love to say that silicon is the new oil. But what does it really mean? Well, think about it. Every single critical modern system, AI, the cloud, 5G, even advanced defense systems, they all run on these things. They're totally dependent on them. And here's the real kicker. Not all chips are created equal. Not even close. The ability to build the most advanced chips, well, that's what determines global leadership now. That's the real power.
Okay, so let's zoom in for a second. Let's start with a really basic question. What actually makes a modern chip powerful? Because it's not just about clock speed anymore. It's not just about making it faster. The real answer is way more complex, and frankly, a lot more interesting.
It really boils down to four key things. First, you've got transistor density. I mean, that's the classic one, right? How much stuff can you cram into a tiny space? Second, and this one's a huge deal, is power efficiency. We'll come back to that. Third is manufacturing yield, and this is a wild one. When you're working at this scale, a single tiny defect can wreck the entire chip. It's not a business problem, it's a physics problem. And finally, there's system integration. How you package the chip and connect it to everything else. Yeah, that matters just as much as what's inside it now.
But of all those factors, there's one metric that is king, especially for AI hardware, and that is performance per watt. See, here's the thing you have to understand about AI. The models aren't failing because they can't do the math. They fail because they burn way too much energy and create so much heat that they become totally impractical. So in the world of AI, solving that power problem, that's everything. It's the whole game.
All right, so we've zoomed in on the chip itself. Now, let's zoom way, way out, because the semiconductor industry isn't just one thing. It's not one company or one country. It's this deeply fragmented, incredibly complex global value chain. The best way to think about it is like a giant conveyor belt that stretches all the way around the planet.
And when I say fragmented, I mean it's extremely specialized. So you've got the chip design, right? That's dominated by the US. We're talking about giants like NVIDIA, Apple, AMD. They dream up the blueprints. But the actual manufacturing, the part where these incredible designs become physical things, that happens almost entirely in Taiwan at one company, TSMC. And the machines they need to do it, those one-of-a-kind, unbelievably complex machines, they come from just one company, ASML, over in the Netherlands. So get this, no single country can do the whole thing.
Okay, I really want this number to sink in. Over 90%. Let me say that again. More than 90% of the world's most advanced logic chips are made by one single company, TSMC, in one single place, Taiwan. That is just staggering. And it's our first huge choke point in this global supply chain.
And if you think that's a choke point, well, here's the second one. The single most critical piece of equipment in this whole process is something called an EUV lithography machine. It basically uses extreme ultraviolet light to print these impossibly small circuits onto silicon. It is one of the most complex things humanity has ever built. And guess what? Only one company in the world can make them, ASML. That's it. A total, absolute monopoly on a technology the entire modern world is built on.
For decades, progress was pretty straightforward. It was all about making faster CPUs for our computers, right? Your desktop, your laptop, just getting faster every year. But then AI showed up, and it didn't just move the goalposts, it completely tore up the field and rewrote the entire rulebook.
And this was a fundamental shift. Think of it this way. Traditional computing with a CPU is like one really smart person doing a list of tasks one after the other very quickly. But AI needs something totally different. It needs extreme parallelism. It's like having a million people all doing one tiny calculation at the exact same time. It's a different kind of problem, so it needs different hardware, like GPUs, which are built specifically for that kind of math and need just insane amounts of memory bandwidth. And the demands of the big AI models today, they are just staggering. It's hard to even wrap your head around it. You're talking about training a single model with tens of thousands of the most advanced GPUs all running at once. And the cost isn't just the price of the chips, it's the power bill. A single one of these AI data centers can suck up as much electricity as a small city. And that right there is why getting your hands on those cutting-edge, power-efficient chips is absolutely non-negotiable if you want to be a leader in AI.
So, you can see where this is all going, right? This is what brings us to the new geopolitical battlefield. This is the exact point where the cold, hard physics of a silicon chip smashes right into global strategy. The race for AI supremacy isn't just about algorithms anymore. It's become a bare-knuckle battle for control over this semiconductor supply chain.
The most obvious example of this, of course, is the tension between the US and China. And you have to understand, this isn't really a trade war. It's a compute war. The US holds the keys to some of those critical choke points. The design software, the core GPU architectures, basically the blueprints. And it's using that control to regulate exports. On the other side, you have China, which is pouring billions into this, but is still struggling to make the most advanced chips at scale. Why? Well, in large part because it can't get its hands on those critical EUV machines from ASML.
So all of this intense competition, this fragile, fragmented supply chain, it all leads to one simple and honestly kind of terrifying question. We know almost all the world's most advanced chips come from one single place. So what happens if that global conveyor belt just stops?
And right in the middle of all of it is Taiwan. You see, TSMC isn't just a big, important company. It's what people in the know call a global single point of failure. Think about that. The most advanced chips from NVIDIA, from Apple, from everyone, they all rely on this one company's factories. If something happened there, it wouldn't just mean your next smartphone gets delayed. It would mean AI development grinds to a halt. Cloud services go down. Advanced defense systems, they stop working. The entire world would feel it instantly.
So here's the bottom line. Artificial intelligence? It isn't magic. It's not just code floating in the cloud. It's physics. It's materials science. It's power budgets. It is all built from the ground up on silicon. And what that means is that in the 21st century, silicon is strategy. There's just no way around it. So at the end of the day, it all comes back to that tiny piece of silicon, understanding how it works, how it's designed, and the incredible global journey it takes. That's not some niche engineering topic anymore. Because in an age that's going to be defined by AI, the people who understand the chips, well, they're the ones who are going to understand the future.
Inside Silicon, the technology behind everything. Powered by Semionics.